All right, good morning. So this is day 2, the first official lecture. Today we're going to be covering chapter 1, chemistry in our lives, from the text. It's not a very long chapter. Well, first let me get into the syllabus. So some people brought up the fact that I left this part in the syllabus with the attendance archive app. We're not taking attendance in the traditional sense, right? I can see who views the videos, but there's no grading for it. So ultimately, you're just responsible for the assignments. The grades that I have will be from Mastering Chemistry quizzes and the test. There's no extra credit or penalty for watching the videos or not watching the videos. So as far as attendance is, I'm sorry, I left that in there. This is from old classes that we met in person, and I missed that, forgot to take it out. So don't worry about that. What else? We got some new tools to play with today. Those of you in the lab, y'all get to play with some new stuff as well. I got the syllabus about outlined. I'll probably post that and the video for the lab around noon. So be on the lookout for that. Not much today as far as lab is concerned, just kind of getting you familiar with the program. But for class today, let's get into it. All right, so chapter 1, this is basically just an introduction into science, chemistry, scientific method. All right, we got some definitions here. I'm going to post PowerPoints, but I'll probably wait until the 3rd chapter. I'll post them in sections because there's not a lot of information in this first chapter. So I'll just wait till I can compile more information, and then I'll drop it all at one time. All right, so make sure you read the text. It adds context. I mean, remembering things are easier if you have a story to go with them. All right, that's just a good style of learning. All right, so first thing they talk about, scientific method. I put a video, or I'm going to post a video, a link to YouTube. There's a YouTube video. It talks about the scientific method in more detail. It adds a couple steps in between observations and hypothesis. It talks about research, which I highly recommend for college students. And then after your conclusion, it talks about reporting results, which in a college environment, you're obviously going to have to do so. But it's not, these things aren't absolute. There are cases where there may not be research to do, or perhaps an error in your experiment means that your results are not valid, and so you don't want to report them. But anyway, scientific method. So what we do is we observe and question, right, what's going on around us. We hypothesize why these things may be happening. We test them with experiments to see if it's true or not. And then based on the results, we draw a conclusion and come up with a theory. All right, so let me talk about theories and laws. You'll see right here it talks about a law, and then down here at the end of the scientific method, we have theories. So a law is something that is absolutely true no matter what. It's been proven mathematically and experimentally. So for example, the book talks about law of gravity. Another thing in chemistry will be the law of thermodynamics, the law of conservation of energy. All these things are absolute, always holds true, and we can prove it several different ways. All right, so a theory is something that hasn't necessarily been proven true. The evidence suggests that it's true. For example, the hypotenuse theory, right, where you take A and B of a right triangle to calculate C. the hypotenuse. A squared plus b squared equals c squared. We believe this to be as accurate as it can be, but it's not proven. Therefore, we call it a theory. But it works, so we use it, and that's how theories are. The theory of evolution is a guide and a tool for biologists understanding the way animals have evolved over time, and it's useful in that context. So theories, just remember that theories are believed to be mostly true, while laws are absolutely true. Okay? Let's keep rolling on along. I'm going to include some of these, some problems dealing with all this on Mastering Chemistry, but I wanted to make sure that we covered it in lecture before I added the problem to Mastering Chemistry. If you have any problems with those, shoot me an email, and I'll try to help best I can. So the book also goes into study tips, better ways to learn. Everybody has their own way of learning. Find what's right for you, and I'll try to accommodate it any way I can. Like I said, no, everybody doesn't have to learn from someone necessarily, right? Everybody can be auditory or visual, or perhaps you can read the book and then answer the questions on your own. And that's the way I was, so I'm not going to penalize people for like not watching the videos. If you can learn it on your own, all the better for you. Alright, so next up, I want to talk about place values, identifying place values. So I got a new tool here. The book talks about ones and tens and tenths. Let me show you how I think about it. So I got, how do I do this? Transition. Okay, make sure this is on. Alright, so when we're talking about place value, let me use the one the book has, 2518. Okay, so this is your ones position, right? Your tens, your hundreds, and your thousands. So straight up is pretty obvious. You know which places are which. Now going the opposite way though, it's always going to be one higher, and let me show you why. 2518. So the way I like to think about numbers is in terms of ratios. So 0.2518 is actually 2518 over 10,000. Okay? So the reason I'd say this is because this 10,000 is the placement of the last number. So this 8 here would be in the 10,000ths with a TH on the end place. Alright? Let me clear this and let's do it again. 2518. So this 1, if I were just isolating this 1, it would look like this. 1 over 1,000. Oh, excuse me. 1 over 1,000. So that means that 1 is in the thousandths place. Thousandths, I don't even know, do you? Thousandths place. Alright? So when you're going behind the decimal, the place value is 1 more than the number behind it. So that's 1 back, it'd be in the tenths position. This one's 2 back, it'd be in the hundredths position. Okay? So there are place values, and that's going to be important, especially when we talk about like scientific notation, and you might have word problems that that you're going to need to write out a number based on what they're telling you. So you're going to need to understand that and how to manipulate that. All right. It's got some basic math in here that most of you should be familiar familiar with, excuse me. So a negative times a negative equals a positive. Negative divided by a negative equals a positive. A negative plus a negative equals a negative, right? Because I'm actually subtracting. So yeah, I mean those, you're going to need to be familiar with that. Percentages are going to be a big key to chemistry. So when we talk about breaking down what's in a substance, a lot of this is a percentage value. It's 30% carbon, 20% hydrogen, 50% oxygen, whatever. All right, so you're going to need to know how to manipulate these values. All right, let's do a couple of examples. So the book's examples are kind of straightforward. Let's do something else. So say I have 10, let me get my pen back. 10 bags of chips, okay? Alright, say 2 are Doritos. Obviously tell I've been doing sitting around here. 2 are Cheetos. 4 are, let's just say like some regular Lay's or something. That's 8. Let's say 1 sour cream. And let's say 1 I don't know, Funyuns or something. Okay. So if I wanted to know what percentage was what, I would take whatever number, say I wanted to find the number of Doritos. I would take, there are 2 Doritos of a total of 10 bags. I divide that out, it equals 0.2. Okay? So 0.2 and a percentage value would be 20%. Oh, undo that. 20%. Okay, number of Cheetos would be 4 over 10. That'd be 40% of my chips are Cheetos. Okay, so let's look at why we do it that way. So you should think about percentages both ways. You should think about a percentage as a percentage, obviously, but you should also think about it as a decimal. So 100% equals 1. All right, it says it's a whole 1. All right, now if I were to say 50%, that actually is 0.5 in decimal terms. Okay, so notice that I'm moving the decimal place 2 times when I want to get from percentage to decimal. And that's pretty much always going to be true. So if I have 350% in decimal terms, that would actually be 3.50. All right? So make sure that you remember that when you're doing your relationships, because when you do math, you're probably most likely going to need it in decimal terms. And then when they ask you to report, you might have to switch back to percentages. So pay attention to that, and remember that when you change to a decimal, you're moving it 2 places. You're moving the decimal 2 places. So let's actually that's another topic. So I'm going to go down to scientific notation while we're talking about it, and then I'll go back to the graphs. All right, so scientific notation is just a way of us expressing. So in chemistry we have very large numbers and some very small numbers. So for example, I may have 8 to the power, let me clear that. I may have 8 times 10 to the 12 number of molecules in a beaker. Okay, and so we express these in different values called moles, or it might be in volume, an amount, a mass, a weight. So, but it's important to be able to use these scientific notations because you can't always write out what this would be 8 with 12 zeros behind it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can't write that out every time. So, but the way to understand it is just like this. So let's look at the one in the book. 2.4 times 10 times 10 to the third power. When you're doing scientific notation, you just want to move the decimal the number of places that is here in the exponent. Oh, that's ugly. This exponent. And you're going to move it in the direction of the exponent. If it's positive, you're going to move it to the right. If it's negative, you're going to move it to the left. So this one's positive. I'll move it 1, 2, 3. Okay, so my number here is actually 2,400. All right. Let's do one more of those and then we'll go the other way. Okay, so say I have 7.6 times 10 to the 5. All right, so write out your number, then move your decimal. 1, 2, 3, 4, 5. Decimals there, add zeros in these little spaces and erase that decimal. All right, add back in your commas. Actually, let me get rid of all these little things there. Add back in comma. 760,000. Okay, so that's how you move to the right. Let's do the other way. All right, so the example in the book is 8.6 times 10 to the negative 4. Okay, so since I'm moving the other way, let me write my number over here in the middle. Now I'm going to move the decimal to the left. 1, 2, 3, 4 places, right? Negative 4. Negative means I go to the left, positive means I go to the right. So let's add in zeros in these spaces. Put my decimal at the end there. Get rid of that one and all this. And that's my number right there. All right. Do one more. So we might have some really small numbers. Let's do 1.13 times 10 to the negative 8. Okay. Since I already know I'm going to have a lot of zeros over here, let me write this on the right side. Now 1, 2, 3, 4, 5, 6, 7, 8. Add my decimal on the end, then a 0 in every gap. Get rid of my decimal. Boom. Let me add that back in. So that would be that number written out, but expressed as a scientific notation is much easier to write. So that's the way you're going to want to do this in chemistry. All right. You also see some other ways that they write scientific notation in the book or in research. So one might be 1.13 e negative 8. And that's actually going to be full. So negative 8. All right. Is the same as 1.13 times 10 to the negative 8. 7.2 E6 is the same as 7.2 times 10 to the 6. All right. So remember that's different than a power, right? 7.2 to the 6th power would be 7.2 times 7.2, so on and so forth, okay? So make sure that you're not doing that. You want to do times 10 to that power. All right. Scientific notation. I think that'll be good. That'll also be on Mastering Chemistry. So let's go back to graphs, equations. Okay, you're going to need to manipulate equations. In here, the sample problem 1.6. talks about P1 V1 equals P2 V2. This is a very common relationship in chemistry. Talks about the pressure and volume relationship. So let's do one of those, and just so I can show you. So P1 V1 equals P2 V2. So you're going to need to manipulate these equations to solve for whatever you need to find. Let's say, for example, I have a balloon that has 10 psi, right, and 2 liters of volume. Okay, psi is a pressure, liter is a volume, pressure, volume. Okay, and then I squeeze the balloon down to a size of 1.5 liters. Okay, and then that's going to be times x. We want to solve for the other pressure. So now you know, if you're just thinking about it in your head, if I squeeze on that balloon, the pressure in the balloon is going to go up. So that's the relationship we're talking about here. As the volume goes down, the pressure goes up. So let's do the math. 20, right? And then we'll talk about units later. How to set up your equation where you're not losing track of your units. But for now, let's just worry about the math. Okay, so 20 on one side equals 1.5x. All right, let me erase this since we're not going to be worrying about units or anything. Just for now, we'll get into that probably next lecture. Okay, so if I want to find x, I have to divide both sides by 1.5 equals x. X equals 13.3. Okay, let's do another. So P1 V1 equals P2 V2. Let's say I have 3 ATM. ATM is also a pressure. In 10 liters. Okay, and then let's say I increase the volume to 40 liters. Okay, and then so my other pressure will be x. Let me put all this in parentheses. Let's do the math. 30 equals 40x. So let me get rid of that. 40x. So 30 divided by 40 equals x, and the pressure would be 0.75 atm. Okay, whatever pressure it was expressed in originally, that's what you want to express it in at the end. Okay, and if I was asking for volume, you'd use liters. Okay. So that's how you move equations. Let's look at one more. So this is also a common chemistry equation. It's the ideal gas law. All right, remember what we said about laws? It's always true. So we'll use this a lot in determining all type of things. So I can determine any one of these if I have the other values available, right? So let's look at, say I want to solve for R, okay? So the way I would do that is I would move my N and my T to the other side by dividing. So PV over NT equals R. Let's solve for something on the other side. Say I want to solve for P. I need to divide both sides by this V to get rid of it. So if I were writing it out, it'd look like this. PV equals nRT. Divide both sides by V, and you get P equals nRT over V. Okay? So I'll put some more of these in Mastering Chemistry. Make sure you're tight on this and that you could do it if need be. All right, because you are going to have to. So put some practice in on that. There's some practice problems in the book, and then like I said, we're going to have Mastering Chemistry as well. If you need to do some more YouTube videos or something to look at that, you can, obviously. All right, so let's talk about graphs a little bit. All right, so let me go up here to this graph. So when we use graphs to understand relationships. Let me use the COVID that's going on right now to kind of explain. So they talk about whether or not the rate of hospitalizations or new cases is going up or going down. They're determining this based on the graphs, right? So you'll see here, you have an x-axis and a y-axis. And if I plot on my x-axis here, I have temperature. The y-axis, I have volume. As temperature gets higher, the volume in this balloon goes up. So that shows us that there's a relationship between them, a direct proportional relationship. It goes up at the same rate, essentially, because this line is straight. All right, so the slope of the line tells us the directionality. All right, so because this line's going up, it would be a positive slope. Okay, and then this one here is going down, so it's a negative slope. That kind of tells us the direction. Y equals mx plus b. I'm sure y'all remember that. Y is my vertical axis value. M is the slope of the line. X would be my horizontal axis values. And then the plus B is my starting point right here. You see, I don't start at 0. I start at 22 point something liters. So B is that starting point. So understanding like how we come up with the graphs, what the graphs mean, it's a big part of science, and it'll help you understand what you're looking at, what's going on. You should be careful though, because we can arrange the graphs in a way that these numbers actually go down. So it starts at 100 and goes lower. And then in that case, the slope may be going up, but it's negative relative to the axis, if you understand what I'm saying. So don't worry about that. Just understand how to read graphs, right? At 40 degrees, the volume of my balloon is just below 26. If I increase that to 50 degrees, it goes up to 26.3 or whatever. So it's a relationship. We can express that relationship in mathematical terms, and that's all a graph is. It's the mathematical representation of a relationship. All right, so I'm gonna put some of these on Mastering Chemistry, and you need to play with it. Email me if you have any questions. Okay, so here goes the scientific notation part. As I said, it could be expressed in different ways. You have to watch a calculator now. So calculators will do this with the exponent, and you have to understand that it's actually times 10 to that power. Okay, so you need to make sure, double check, triple check your calculations when you get into it. Make sure that you're not doing 7 to the 4th power as opposed to 7.52 times 10 to the 4th power. All right, and when we start doing some more practice problems and get into the nuts and bolts of the math, I'll do some more examples and show you how I manage a calculator to keep me from making those mistakes. Okay, so yeah, that's pretty much it for chapter 1. Like I said, I'm going to post the Mastering Chemistry problems very shortly, and I'll have the lab up by about noon. So Yep, y'all. Let me know if you have any problems. I check my email pretty regular, so I also put my phone number on there. I think some of you taking advantage of that already. No worries. I'm here to help any way I can. Uh, Let me know any concerns or questions you have. I think that's about it, and I'll see y'all tomorrow.